Hello and welcome. In today's lesson, we are stepping into the world of number systems, starting with a very important concept: rational numbers. Imagine walking along an endless number line. You start at 0 and begin collecting numbers. First come the counting numbers 1, 2, 3, and so on. These are natural numbers. Add 0 to your collection. Now you have whole numbers. Go backward and grab negative numbers like -1, -2. These form integers. But what about the numbers in between like a half, -3/4, or even 2005 divided by 2006? These in-between numbers are called rational numbers and they help fill the gaps on the number line. So what is a rational number exactly? A rational number is any number that can be written in the form p divided by q, where p and q are integers and q is not equal to 0. Let's have some examples. 1 by 2 can be written as p will be 1 and q will be 2. Next, -3 by 4 becomes p will be -3 and q will be 4. 7 can be written as 7 by 1. Even 0 is a rational number. This means the set of rational numbers includes natural numbers, whole numbers, and integers. It's a big family of numbers. Did you know a rational number can be written in many equivalent forms? For example, 1 by 2 equals 2 by 4 equals 3 by 6 equals 50 by 100. But to keep things neat and consistent, we use the simplest form, where p and q have no common factors other than 1. This form makes it easier to compare and plot rational numbers. Any number that can be expressed as a fraction of two integers is a rational number, and they show up more often than you think. Rational numbers are everywhere in real life. Eat half a pizza? That's 1 by 2 is rational. When your teacher says you got 17 out of 20 in a test, that's 17 by 20, a rational number. Temperature of 37.5 degrees Celsius? Again, a rational number. Even repeating decimals like 0.333 and 0.666 are rational because they can be written as fractions with integers. Every rational number has a predictable decimal pattern. They are either terminating, like 1 by 4 is 0.25, or non-terminating but recurring, like 1 by 3 is 0.333. These patterns repeat forever and are easy to spot. If the decimal ends or repeats, it's a rational number. This feature is a great way to identify rational numbers from decimal form alone. Let's learn to locate rational numbers on the number line. Example. Find 5 rational numbers between 1 and 2. Step 1. Write 1 is 6, 6 and 2 is 12, 6. Step 2. Pick numbers in between. 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. Each one lies between 1 and 2 and is rational. This shows us that between any two rational numbers, there are infinitely many more. Let's bust a few myths before we end. If you have a myth that rational numbers are only positive, that's not truth is, they include negatives and 0 too. If you have a myth that fractions are different from rational numbers, that's not truth is. All fractions are rational numbers as long as the denominator isn't 0. Quick recap. Rational numbers are of the form p by q, where p and q are integers and q is not equal to 0. They include natural numbers, whole numbers, integers, and fractions. They can be represented in multiple ways, but we prefer the simplest form. You can find infinite rational numbers between any two given numbers.